Welcome back. We have just a couple more electron configurations we want to work on. We're on page 16 of your notes, and I'll try to follow them much more carefully than I was before. Sorry about that. Now, let's take a look at example 517 to start with. 517 asks us about yttrium. That's symbol Y, and it's number 39. So if you find yttrium on the periodic table, it'd be right there. So let's go ahead and start our journey and do yttrium's electron configuration. Start at the beginning. We'd have 1s. We're going to go all the way through that. Start left to right again. We'd go through 2s2, cross the ravine. We hit 2p6 because we're going all the way through it. Back to left to right. You're not wrapping, you're always starting left to right. 3s2, cross the ravine, and we've got to go all the way through that 3p. So we have 3p6. Backtrack to 4s2. Now remember, we've got kind of go down a hill when we get to the D block. 3d10. Going all the way through, and then back up a hill when you hit the P. 4p6. Over here, then we'd have 5s2, and then we'd have 4d1. So now let's answer some of the questions. I'm going to skip the orbital diagram. I will show you that in class. So our highest energy are the last ones we were filling. And so these are our highest energies. It's the last sublevel that we were placing electrons into. Now, the next said, which are the farthest away? Our outermost. Our outermost are these 5s. They're the furthest from the nucleus. Now, if our outermost are also the outer s's, remember that outer s and p, well, we don't have any 5p, so we can only talk about the outer s, are called our valence. So we would say that we have 2 valence electrons here. Now, the ion that yttrium forms, it's possible. I'm not going to tell you it does that because that's not what we're after right now. Possible. The first thing yttrium could do is to become yttrium 2+ if we lost those 5s2 electrons. We typically lose our outer s and p first. Now, it could also become yttrium 3+. And that would be if we lost the 5s2 and that 4d1. Now, in theory, that is possible. Now, I want you to write down yttrium's yttrium 3+'s electron configuration. Now, I'm not going to do it right now, but you notice if we lost those 3, I'm going to line them all up in a minute. If we lost those 3, we have the same electron configuration as krypton. So H in your notes would be krypton. Okay, so since yttrium 3+ is the same as krypton's electron configuration, we say they are isoelectronic with one another. Okay, so hold on to that word. That's really, really important. That's one of the goals of ion formation, is to become isoelectronic with the noble gas. Now, let's take a look at bromine. Bromine is right here on the periodic table. Now, remember, bromine is a non-metal, whereas yttrium was a metal. Metals are losers in the electron game, and nonmetals are winners in the electron game. Okay, now bromine's electron configuration, we're going to start here. We'd have 1s2, then wrap back around, 2s2, cross over the ravine and get through the 2p's. We'd have 2p6, backtrack to the 3s, cross the ravine to the 3p's, backtrack to the 4s. Now remember, you've got to go down a little hill. In other words, it goes down to 3d10 and then back up the hill. So we go down the hill and back up. Because remember the D block, n is 1 less than the period. So 4p5. So that would be bromine. Bromine would have, just to refresh your memory on this, bromine's noble gas, you go to the previous noble gas, and that previous noble gas to bromine is, I'm looking up on my periodic table, is argon. So this would be argon, 3d10, 4p5. Now, bromine's right here, and notice that if it just gained 1 electron, it'd be like krypton. I'm going to draw out an orbital diagram just for that 4p, just for those outer electrons. Be 1, 2, 3, then we pair with opposite spins. Now, if there's something around to do it for it, bromine can gain 1 electron right here. So if bromine gains 1 electron, it would be argon. I'm just doing this to simplify for you. 3d10, 4p6. And that would be the bromide ion. And it's isoelectronic, again, with krypton. Isoelectronic with krypton. Same electron configuration as krypton. Now remember, yttrium was the same as krypton. So we can say that, let me get myself a little bit of space here. Hopefully you've written all this down. Our conclusion here would be yttrium 3+, krypton and bromide are all isoelectronic with one another. With one another. Okay? So that's a key word that we want to get down. Wow, I'm not spelling very well with my mimeo tonight, and I just messed that up. So isoelectronic with one another. Okay? So hopefully that gives you a good starting point so that we can finish up our homework on this. And then we will be doing an inquiry on the last part, which is periodic trends. Okay? And so that gives you some of our background for what we're doing there. Now I'm going to check my time. I think I have time. We'll do this in class. When we get in class, I want you to remind me to do tungsten. And we'll walk through the periodic table together and make sure we're all on the same page with how to do that. So, until then, this is, now I think I'm pushing a button here. Y, B, C, T, signing off.